question is just a simple type of the previous one we learned. So this has to do with two protons of the same charge. And we have been asked to find the net force on these two protons. What do we need to do? The two protons have the same charge. They have the same charge, you heard me right. But there is something we need to do. If we have Q1 is equal to 1.6 times 10 raised to the power minus 19 coulombs, and then Q2, 1.6 times 10 raised to the power minus 19 coulombs, it means that Q1 is equal to Q2, and that can be just Q, right? Then we'll take into consideration the distance separating them, where R is the distance separating them. And that distance is given as this, 5.3 times 10 raised to the power minus 11 meters. So what do we need to do here? We quickly state. What we need to do here is to quickly state the formula once again, which is F and net force is equal to K and Q squared all over R squared. Alright? Where the value of K can be found using 1 all over 4 pi epsilon naught. And this gives 9 times 10 raised to the power 9 Newton meter squared Coulomb squared. That's what it means. If we have understood this, then we can substitute. Our formula now becomes Fn is equal to 9 times 10 raised to the power 9, and then Q squared all over R squared. With this, we can now find the net force acting on the protons, even though they are two. They have the same charge. Take note of that. So what do we do now? We put completely what we have, Q. Q now becomes Fn, let's take it this way, brackets, 9 times 10 raised to the power minus 9, and then 1.6 times 10 raised to the power minus 19, all squared, all over the distance separating the two protons. Look at it. So R becomes 5.3 times 10 raised to the power minus 11 meters squared. We must take note of that because all that's squared. Okay? If you have watched up to this moment, come on, give me some thumbs up, subscribe that red button, share. Put on the bell button for constant notification, and then belong to this family, right? Okay, let's go. What we have here is very simple. Now we have found this. Fn is going to be, by the time we simplify this, by the time we take the simplification of all this and then divide by the distance separating them, we are going to arrive at 8.2 times 10 minus 8 Newton. Look at it. You can see this is the force acting on these two protons. Even though they have the same charge, we must take note of this. But there is a question here we need to answer. There is a question. Quickly, we need to answer. We need to address this. Maybe in our subsequent classes, we are going to address this. If the nucleus of an atom contains protons, maybe 2, maybe 3, depending on what we are trying to treat, and you know that protons have positive charge, that means there should be some amount of repulsive force, just like you can see. They are repelling against each other. They are not getting attracted because they have the same charge. Positive. Now, why is it that since this is the case in the nucleus of an atom, the nucleus of an atom has not torn apart? Of course, repulsive force is capable of tearing the nucleus apart. Why hasn't it happened? That's my question. We need to address it in our subsequent classes, because it's going to take time for us to understand that. And we can only address by the time we understand the concept of Coulomb's law. I will end it here and urge you, before I leave you, let me quickly put on my glasses, okay? Once again, this will make you know that this video is different from the first one. Alright? So, before I let you go, subscribe. Quickly subscribe. Give me some thumbs up. And then share with your friends, students, networks, community, parents that love things like this, especially students in sciences, right? And don't forget that you need to belong here. My returning subscribers, big thumbs up. My new subscribers, I'm giving you some kapam, belongs to this family. I sign out to prepare for next class. See you.